Okay, so can you do like a 1 minute intro? You don't have to like give specifics, just like who you are, what you're looking for, stuff like that.
Okay, so I am working as a senior software engineer, and I am looking to interview for FAANG companies right now. Yeah,
Okay, sounds good.
for info positions. Yeah,
Okay, so oh yeah, did you want Python by the way, or do you want to switch?
Java.
Okay, there's a Java tab as well, so
Did I?
I'm gonna delete the Python tab, and you should be in the. I think I can reset it so it'll have code. Okay, is that good?
I thought I was in the Java. Am I?
There were
Yeah.
two. Yeah, yeah. It looks like you're in here. Yeah, yeah. Okay. Okay. So here's the first problem, and you can go ahead.
Okay. There's a string, and then there's a word dictionary written through. If it can be segmented as lead and code. Okay, and okay, so I'm trying to understand what does it mean segmented? So if there's a word, is if there is some dictionary, something with just CO, is this still true?
1 sec. I gotta refresh. I don't see you typing. Okay, so if the word is so this would not be true because basically you need to break down the original string into words in the word dict, and you can reuse the words multiple times. So if it was leet co, the de part wouldn't be able to be broken down, so it'd be false.
Okay, so let me look at this. So okay, apple, pen, apple. Okay. Uh, um, So segmented as in, I'm just trying to understand like what
Hmm?
it means. So we are saying that from, so I understood, like from here it's defining as segmented, but from here, if I'm looking at from the dictionary side, I should be able to form the word.
So basically, I guess I can explain it better. So if you take this S and you break it down into a bunch of chunks like this, every
Mhm.
single chunk will appear in word dict. So is there a way to break down S into blocks where every block appears in word dict? So like in this case, there is an example one. Same thing in example two. I could break it like this.
Mhm,
Does
mhm.
that make sense?
Okay, and then so it should be completely broken up into this dictionary,
Hmm.
right? Like, there should not be anything remaining in the initial string.
Hmm.
Um, okay. Okay. So just or for the brute force part, right? So what I would do is like for a given string, there can be multiple substrings, and each substring, if it's present in this word dictionary,
Hmm.
I will check for the remaining substring, and the same thing, like once I find it, because we can find it multiple, like we can repeat it multiple times,
Hmm.
the word list will stay the same. Check if there is a substring that's present, and then for the remaining substring, it's the same, like in a recursive way we will be doing the same thing.
Hmm.
And then at our end check will be, have we reached at the end of the string or not, like for the last word, did we find it? So everything should be true for each
Yep.
recursive.
Okay, so
And
just to summarize what you basically said, so you're going to look through the string, and then for every single substring you find, you will basically recurse and check is the rest of the word, uh, can the rest of the word be broken down? And then once you get to the end of the word, then you know it's like a yes, so you'll just like bubble up and return yes.
correct, yes.
Okay, and what's the time complexity of that?
So that would be if the string is of the length n,
Hmm.
for every I and j, right? There will be n square substrings, and for each n square substrings, for each substring, we will again look for the uh, if it's a the remaining part is a substring. I think it just n cube.
Okay, yeah. So basically, so this is pretty good start.
Okay.
But so
Yeah,
you
yeah.
basically
Just
said,
trying to put it out there, like what can be done in a wild brute force world. So
hmm,
I'll see like how I can kind of
hmm,
optimize
yep,
those parts. Uh, no, when I'm saying recursion, one thing I'm thinking of is like, can this be done um, with the sub problems way, where we
hmm,
know if this part is already true, right?
yep,
Uh, can so so when we find lead, right, and
hmm,
then we find code, and then we'll look for DE, and if it was D is not there, then we'll check for ODE, that kind of a thing. But if we are doing like multiple for the same substring, what we can do is we can do a memoization for that thing
hmm,
rather than finding it again. That's kind of like a top-down memoization, I'm thinking, but we can do bottom up also. I'm just
hmm,
trying to think what we can do for the bottom up part. The base case would be the empty string is true. But what we can do is for every word in the word dictionary, what I can do, I'll check if that's present in this. If the lead is, for example, code is the first one, I'll check is this code. If it's not there, is lead present?
hmm,
Then once it's present, I will skip it, right? Uh, and again find from there again I'll iterate through the words and see if that's there.
hmm,
But what I can do, when I was mentioning the top down, right, what I can do is mm, once I find the word, I can make that index as true in the DP array of the size s length.
hmm,
And um, when I'm at code, I can see is this minus wherever, like if I find this code
hmm,
in this string before code, if I find it, was DP true at that point, and if the whole thing is there, then I can make the DP at this index as true. Rather than just marking this, I'll have to mark the whole string.
yep. So are you traversing with the bottom up from the front or from the back of the string?
I will be moving from the front part and I
Okay.
will iterate through each word.
Okay. And so you're basically okay, so like you move from the front, and
Mm.
so you're basically gonna check like if the word is there,
Mm.
then
And
so
then mark it
let's say like you
through.
found lead here and you had
Correct.
this DP array. So let's say this was like this, right? Like what index would you mark true if you found lead, I guess?
It'll be of the S length plus one. Okay. And now DP of length zero will be true. This is to mark for the lead part.
Uh-huh.
Once I find the lead part, I will mark this will be false, false, false. Initially,
Mhm.
everything will be false. Let's mention that.
Mhm.
Lead code, right? And then now first thing this is I'll see the lead, right, and
Mhm.
then that will be here. And LEET, and here I'll check previously to this, which will be the empty string. Is that true? So I'll mark this as true,
Mm-hmm.
and then I will, if there was, for example, let's just say lead C,
Mm-hmm.
I'm going to mark lead C is also as true from here.
Mm-hmm.
Sorry. And then so once I finish this, so code, I'm not going to find it here. Once I finish this, then I'll have to start from E,
I
right?
see. Okay.
And then if something was there here, EC,
Mm-hmm.
I'll ET, something like this. Then I will mark ET. I'll check if I can mark it, and then I'll see if L was present. Then only I'll mark the whole thing lead as true.
Yeah, so this makes sense to me, but so basically you're saying like I'm starting at index 0, I'm going to mark it true, and
Correct.
then I will compare from index 0 to every word, and then I'll mark like the end thing true. So
Mm-hmm.
then you said you'll go to the second one. So
Mm-hmm.
do you need to go to the second one if it's false? Like, because it already tells you that like if the second one is
Here
false, it
it's
means you
not
can't
for.
get here, you can't get there, right? So
Sorry, I think I spoke over you. What was that?
yeah, so let's say you go through these first words and you mark
Mm-hmm.
like this first part, right? You mark leet, you mark leet C, and
Mm-hmm.
that's all you find, right? So
Mm-hmm.
basically, like this becomes true, you said, and then like this becomes true, something like that, right?
Mm-hmm. Mm-hmm.
And then you said you're going to go to the E and you're going to
Mm-hmm.
check everything starting from the E to all these
Mm-hmm.
words again.
Mm-hmm. Mm-hmm.
But the thing is, like, because E is false in your DP, it means you couldn't get to the E, right? So do you
Correct.
have to even do anything at the E or can you just skip?
Yeah, we can just go to the next true one
Mm-hmm.
and then try to find the next word because it's a connection. Yeah.
Yeah. And then what's
Because
your like base case here, I guess? Like what are you trying to achieve at the end?
what am I trying to achieve is like the whole last word, it's true. We took the S length plus one, right? If that's
Mhm.
true, that means each and every, so that word we can trace back what all the words we picked from here, and then where we probably not, but yeah, we'll have this as true mark because of the lead code and not lead C.
Mhm.
So if I have this as true, I think we can break it into the words.
Okay. So I'm happy with this. If you want to write any more notes, you can or you can code up to you.
Yeah, the only base case will be the empty string is true, and then we mark all the words from zero index, and then the next index I look for is in the DPR in the next true.
Mhm.
And then from there, again, I'll try to find, I'll iterate through the whole word dictionary and then find it.
Okay. Yeah, sounds good.
Okay. Yeah, something like that.
And one last thing before you start coding. So I think the first one you said was like n cubed. So what does this bring it down to?
This one, we are just doing one parse in the top string, and
Mhm.
then we are iterating over the word of dictionary
Mhm.
again and again. So if this is, there are W words, and the length is L, the
Mhm.
string length. I think the worst case would be everything being true, so L into W.
So L is the length of the word.
Yeah.
So wouldn't it be WL times S or N or whatever?
I think I've
Because like for every character you have to compare it to every word or like every starting index, something like that.
if this is sorry, what was it?
Yeah, so basically, so I get that WL, right? Comparing every word is WL, but then you're also
Mm-hmm.
comparing every word to every index in S. So it's still like S. So I think your first time complexity was a bit off. I think it's bigger, and now it would
Yeah,
be
I
like
think it's, yeah,
SWL.
yeah, yeah, yeah. I think it's the, yeah, it's. What is it? I think it can it be like
Yeah, so basically like,
factorial?
oh yeah, go ahead.
Yeah, n power n. Yeah.
Yeah, it's fine. Okay, this is good. Okay, let's just start coding to make sure you don't run out of time.
Okay.
And because we're not running this, you can just write a function if you want to. You don't need to have a main. You can do whatever. Up to you.
Okay. And then what we are returning is a boolean, and we are saying and then we have a string s, and then this is a list of string. This is words. We are trying to see if it can be segmented. Okay, so now the first thing is a boolean dp array. Now we have the base case as dp of 0 equals true. Now what we're going to do is we can say int I equals 0, and then while this is for the index, and we are going to skip the index in between to the next truth part. So I'm just having the while loop, and when I'm saying the index is less than the whole length, right? And then we are going to look through the string, and now we have a for loop. We are going to go through each word. For this, what we are going to look is we are going to check from whatever the word I to the size word length. Okay, string cur equals s dot substring, and this one will be from I, and this will be of the size words dot get j dot length. So if the length of the word is 4, what I'm going to say is 0 to 4. That will be 0, 1, 2, 3. Okay, now I will say 0 plus this word. This will be my current word, and that is this equals if cur equals and words dot get of j. Now what we have to check to mark dp of I plus this is I'll have to check this is true, but anyhow we are going to start with the true only, so I would say initially it is 0, so for every word, and if that's present we can just say when I0, this will be true. Okay, now after we mark all the words which is here as true, now what we can do is I equals we can say here dp of I, if it's sorry, if dp of not I, then I will say continue. Okay, if dp of I is true, from there I'm going to check it, and after all of this I will simply do I plus plus. After I mark everything, I come inside and I can just do here an I plus plus for that. Or I can just say okay, and I will mark from there, and okay, at this point I will return dp of s dot length plus 1.
Okay. Are you happy with this?
For every word I get the next substring, and then if this of that length, and I'm just checking, and I can mark it true, and I keep yeah, I think this is
all right. Let's do a dry run on example 1.
okay.
And
Sure.
you can make it less words if you want to. Or you could pick something super simple.
I think that's good enough. And if this is there, right? So initially I is 0, and then it is true. So j equals 0, which will be the lead one. And now the curve will be from s dot substring of 4. This from s 0, 1, 2, 3. So this will be the substring, our curve, and we are going to check if this equals the word this one, and then so we're just going to mark dp of initially I is 0, and we are just saying 4.
You can just add the DP array below this. It'll probably make it easier for you. Just make it all falses and just mark as you go.
Yeah, let's do that. And then one, 2, 3, 4, 5, 6, 7, 8, 9. Okay, initially this one, and then okay, so now we're going to mark this as true. And then what else? And then we will probably mark this also as true, because it's the same thing, j equals 1, and this time this is 5, and then I will see that this is uh, equals, the curve will be lead C and the word is lead C.
Mm-hmm.
We'll mark the DP of 5 as true. And then what is the next word? Code, we will check, get it. It's not equal, so we'll not enter. Eat also the same thing.
Mm-hmm.
Now, what happens? DP of 1, it's not true. So we just skip DP of 2, 3, 4. It's true. Now, when we are at 4, we'll again have to go through the J equals 0. We are going to get 4, which is 0, 1, 2, 3, 4. And then of the length C, that will be our cur substring. Of the length 4, it's not the same thing. We'll, okay, now that's okay. Now there is an edge case that we are missing. Okay, so this will be out of bounds.
Okay, so you don't need to fix that out of bounds just because we're a little bit low on time, but it's good that you caught that. Think about this line as well. Is this the correct index?
Which line?
65.
65. Oh, okay. Okay, yeah, I think it should be just the index will be the DP of S of length, yeah.
Mm-hmm. Okay, so let me ask you one quick follow-up. You don't have to code. So right now you are doing string comparison with like basically brute force string comparison. So without coding, are there any better ways you could have done this? Imagine these words are like really long. Like this S is like 1,000,000 characters. These words are like 1,000 or 10,000 characters. Is there a better way you could have compared?
One thing is use a hash map for the word or like character frequencies and like 26 size, and then kind of compare that, or just hash it.
Hash what?
Hash the strings and then just compare the
Okay.
uh,
So compare like hash values or something?
yeah, yeah,
Okay.
yeah.
Yeah, makes sense. Okay. Okay, let's move on. So I think we have about 23 minutes left. So I just want to make sure you have time.
Uh-huh.
So we'll do another one. And this is the second question. Okay, so I'll just paste it below. And here's an example.
Okay, you need to implement a function pick index which randomly kind of picks an index 0 to inclusive, and the probability of picking an index I is this. Okay, the probability. Okay,
And then I'll give you
okay,
starter code as well.
okay. Now there's like a weight array, and the probability of picking index 0 is 1 by the whole sum of that weight, and the probability of this one is okay. We are talking about, and we'll have to return the index. Okay, right off the bat, what it feels like is we have to pick something. 1 second.
Sure.
Oh, laptop is on charge. Okay. So right off the bat, what it feels like is this array, if there is a sum of all the weights, right? And I'll have to pick a random number in that sum, 0 to like for example, 1 and 3, 0 to 4, pick a random number in that and kind of map that back to the weights. If there was like 1, 2, 3, 4, 5, um, right, the weight of this is more. So if I pick in the sum, what is the sum of this?
15, I think.
15? Yeah, 15. And then if I pick the last 10 to 15, that should be mapped to 5. And the numbers before 4, like kind of map, uh, do a uniform distribution in the weight 0 to 15. And then pick a random number in that and kind of map that to this thing, is what it feels like. So for me to I can do the same thing. I'll kind of calculate the sum of these elements,
Mm-hmm.
find a random in that 0 to 15. Now if I got 11, now if I got 11, how can I map it to this index, which is 0, 1, 2, 3, right? Uh, which should be this, but maintain a prefix sum. So I know something like 3, and here 6, and then 10, and then 15. Now I know if it's 11 to 15, I'll have to pick the next greater element. If it's anything between 6 to 14, I'll kind of do a binary search in this sum array and find the appropriate index and map that to the index of the original array, something like that.
Okay, so you mentioned 0 to 15. So why would you say it's 0 to 15? Like,
The
imagine you have some small stuff, like you have a 1 and a 1. So what would this look like? Like, would you do 0 to 2? Like, basically, a 1 and 1 should just be 50-50, right?
Correct. Yeah, excluding 2, I meant, like, yeah. In the rand method, it's kind of exclusive. Like if you just call
Oh,
rand or
I see. So here you would get 0 or 1.
0 or 1, and then yeah, 50-50. Yeah.
Okay. And so once you get the number, you basically said you have a prefix sum, and then what are you
Yeah.
looking for? Like, what's your thing
So
you're looking
now,
for?
yeah, 1 and 1, right? So now we have 1, comma 2.
Mm-hmm.
Right. And now in rand of 2, I'll either get 0 or 1, right?
Mm-hmm.
If I get a 1, I'll have to pick this, and then if I get a 0, I'll have to pick this.
Right. So can you kind of state, like, given a number, I'm looking for X, in like in my
Yeah,
input?
I would say just for the simplicity, I can
Mm-hmm.
just say 0 and 1. It will be the outputs of my rand of sum, right? Which is 2
Mm-hmm.
here. Uh, and then it can be this, and now from that I'll have to search in this sum. So if I get a 0, I'll have to go to the right. I was thinking like binary search. I can just like do, because I'm doing -1, maybe I can just, after I get the rand, I can do rand plus 1, which will,
Mm-hmm.
again, we are pushing it. Now if I get a 1, I'll just, including, I'll try to search in this. And
Mm-hmm.
then if I get a 2, I'll try to search in this. Same thing here. If I get 14, right, I'll have to look for 15 in this. And if
Mm-hmm.
I get a,
Okay. So you're binary searching. So like if you get like 14, you
mhm.
would look for like what? Like the smallest number, like bigger than that or something?
Yeah,
Or
yeah,
like
yeah, yeah, yeah,
okay.
yeah.
Okay. Yeah, that sounds good. So yeah, so you this makes sense. And then what's the time? So imagine like I don't think I said this, but yeah, so this makes sense. So basically, we're going to be calling pick index a bunch of times, which is good because like so you do this like pre-computation and then you do this binary search. So what's the time complexity of like the setup, and then what's time complexity of pick index.
Okay, time complexity of the setup. We are doing a prefix sum. So if n is the length of the array, it's big O of n. And then now we're going to do a binary search every time. It will be log n.
Okay, yeah, it sounds good. So if you have any other notes, you can write them down, or you can code if you want to.
I think I'm good. Yeah, the rand plus 1 will be the key. If not, I think this is good. Yeah. And yeah, so I think 0, 1 will be again to 1 and 2. If I just do the binary search, it's fine. I just wanted to look at it. So we'll be doing rand of 15, right? In rand of 15, 0, 1, 2 should be mapped to, not really, just 0 should be mapped to 1, which will be searching for 1, and then in that weight of 15, 1 and 2 and 3, 0, 1, 2, 3 will be mapped to 3, the weight, I mean the index 1. So if I get in this rand of 1, 2, 3, I'm going to do the target plus 1, which will be 2, 3, 4. And
so I'm confused. Where'd you get the 0, 1, 2, 3 from? Like, yeah.
Just the way
You mean if these are your numbers?
Yeah. So
Okay.
I'll be doing the rando from that, right?
So you can pretend that nothing has a 0. So there's going to be no 0.
Yeah.
So like every number has to be 1 or bigger.
So yeah, because we are just anyhow doing the plus 1, so everything will be normalized again back to 1 and 2, 3, 4. Okay,
Yeah.
the weight is 2, so I was thinking the number is 2, so I got confused. Okay, so the prefix sum is 3, but the weight is 2, so 2, 3 will be 3. So yeah, that looks good. Okay, so this is kind of the, let's have the int prefix sum and this prefix sum is equals to new int w dot length. Now for each prefix is equals to prefix sum of I minus 1 plus where of I. The edge case here will be, let's just say prefix sum of 0 equals where of 0 and just 2 from I equals 1.
Alright.
Alright, and we will have the prefix sum here. That's done. Now pick index. We will have to return an index and what? I think we can just have random and I don't think we need this, but sure. Now we will have int dot next int of prefix sum now the 2 and 3 should be right, and then 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is kind of the distribution. And so if I get an 8, it should be here to the rightmost. Okay.
Oh, I see. You're like breaking down the chunk into what index it will be. I see. Okay.
So 4, 5, 6. That's fine. So now our target will be this plus 1, right? And now
So random next int gives you a from 0 to whatever you pick. Minus
yes.
1. Okay, got it. Yep, sounds good.
So here it's 4, 5, 6 will be this, right? Even if I got 4, 5, 6, sorry, it'll be this. So anything greater than 3. So it's kind of just the insertion point. If I have to insert this 4, 5, 6, also I will be inserting here. Just thinking what happens to the equal number. If it's not there, it's fine. If it's there, we get a positive number. So I think that's fine. And that's the okay. So I can just get away doing the arrays.binary search, and I'll try to find my index. So this will let me just go ahead. So now what happens is so this is kind of the weight distribution, right? If I get 2, 3, I have to I have to find for 2, it should be the index equals, let me write it down, 0, 1, 2, 3 and 4, right? So if it's a 2, 3, I'll have to get an index at 2, which will be 2. It's the insertion point is this. For 3, they found it's going to be 1. So arrays.binary search will return 1, and I'm good. For 4 by 6, again the insertion point will be 2. For 4, 5 and 6, I found the element. If it's a positive element, I'll just return it. This will be my pick. If it's a negative element, I'll just normalize it back to the index by doing minus index minus 1 and kind of return that.
I see. So it's basically like where it would be inserted in sorted order, and if there's a tie, it will go to the left.
Correct.
Okay, yeah, sounds good.
So this will be arrays.binary search in this prefix sum. Okay. And I will check if my index.
So since we have a little bit of time, can you not use arrays binary search and just write it yourself?
Yeah, sure. I can do that. It's just the insertion point, right? Let's take this off. Then I don't even need to handle this anyhow. So what I can do is private binary search, and what this takes is a array, and it takes a target. Right, and what we are going to search here is, even if we don't find 4 in this array, I need the rightmost index. Okay, so int low equals 0, high equals array dot length, and then I would say while low is less than or equals high, we find it, right? If okay, let's kind of calculate the mid equals low plus high minus low by 2, and we say if we find equals target, we return the
Okay.
else what we do is else if array of mid is sorry mid is less than arrays of we have a low and if it what is it target, what does that mean? Our mid is way before it, so we have to check in the right for the target. So our low equals mid plus 1, else we check the left side. Okay, and this is fine. Then when do we stop? When low crosses the high, right? In a way, it's high and then it's low, and we need the rightmost index that will be at the low, so we can say return low.
Okay.
And then we will be returning that.
Okay. And are you happy with this?
Just need to check for the edge case.
Mm-hmm.
The binary search is always so this one, right? And I'm looking for 4. What happens? Low is 0, high is 4, and now mid will be 2, and now which will be this, and I am looking for target equal to 4. What I'm looking for is not this, so I will check the arrays of mid. 6 is less than the target, no, so my high becomes 2 minus 1, which is 1. Now I come back again, it's 0, 1, mid is 0. Now array of mid is target, no, array of mid is less than target. So my low becomes mid plus 1, which will be 1. So this is still at 1, and mid is also this. Now if array of mid is less than target, I will do mid plus 1, which will be 2, and then kind of low is not less than, and then this will be that. Yeah, I'll get the rightmost index.
Okay. Yeah, I think this is good, and this is kind of like a dry run because all we really care about is the binary search part. So, okay. Okay, so I think let's go to feedback now. We're right at 49 minutes. So, actually, let me see if I have any follow-ups. Oh, yeah, I have one follow-up for you or it's not a follow-up, but just something in your code. So on 113, do you see any problems?
Yeah.
Okay, and there's one more.
This one, right? Do length minus 1. What am I saying? Get the last.
Yeah, it was basically both of those. Like you don't have access to W and you had the off by 1. So I think it's good now.
Yeah, this is, yeah.
Okay. Okay, so yeah, so before I give you feedback, how do you think you did? Like, what do you think you did well? What do you think you can improve?
I think I'll have to improve on the. I don't know. I feel like if I have to rate myself, I would rate it around 6 out of 10. Like,
Okay.
maybe kind of think quicker and try to understand what it's needed. Yeah.
Okay. Yeah, so I'd say I think you did very, very well. So I think 6 out of 10 is like, I mean, I don't know, like maybe you have like maybe you bombed a bunch of stuff, so your self-confidence is low, but you said you just started studying, and I think for just started studying, you did quite well. Um, so I'll just go over like my breakdown for both of them.
Okay.
So I think for the first one, you asked about like you already said the problem you asked about some edge cases. So some free points probably worth asking is like, what if some characters are uppercase? What if some are lowercase? Like, how do I compare them? And then I don't think you handle the empty string, so it's like, can the string be empty? It's like that kind of stuff takes like 2 seconds. And like, if I did want you to handle something, like maybe I wanted an uppercase character and lowercase character to be equal, and you didn't do that, and you didn't ask, like that's not great. But that's like really easy stuff you can improve upon. It takes like a minute.
Okay.
Um,
Got it.
yeah. And I think so there's like 4 parts. I usually write down scores here.
Mm-hmm.
So there's like problem solving, which is like, okay, you read the problem and then you write a solution in like pseudocode. I think you were very, very good at that. You recognized it was top-down DP, and you were confident enough to do bottom-up DP in an interview, which is pretty crazy in my opinion.
Mm-hmm.
So there, I would honestly recommend doing top down. On like, I'd be like, so I'm gonna do top down, and if you want bottom up, I can do it. But basically, bottom up is longer and is more error prone. Like top
Mm-hmm.
down is very like intuitive, and you can code it in like 5 minutes.
Mm-hmm.
So your one of your biggest things was like, so this was 50 minutes, and you took 50 minutes. So for like meta or whatever, you only have 40.
Mm-hmm.
And so you really want to speed up like all the areas you can. So don't overcomplicate like your own solutions for you, like if they're good with top down, just do top down. You'd probably save 5 to 10 minutes coding, and explaining as well. And if they are like, no, do bottom up, then like, sure. So,
Mm-hmm.
so I would say that, but yeah, quite impressive that you did do bottom up in an interview.
Mm-hmm.
Uh,
Yeah,
and
I
then,
think that's definitely something I have to. I put myself in unnecessary complications. I feel, and
yes.
when explaining also, I felt like was not able to get my thought process through. I think I'll have
Yeah,
to.
but with top down, it's like very easy. It's like, oh, I have these like recursive cases. Whenever I get to the end of the string, I know it's true. And then like whenever I have the comparison, I know that it's like, yeah, I can go to the next thing. Like it just like it's a lot easier to explain. You don't have to think like, am I going from the front or the back? Like what are all my like? It's just way more intuitive, and it's
Mm-hmm.
also way faster to code and way less error prone. So that's
Mm-hmm.
what I would recommend. Um,
Mm-hmm.
Okay, and then the let's see. Yeah, so I would say your like problem solving is like very, very good on this problem. Like you basically figured out, so there is more optimizations here. You can use like a try for better word comparison, but like if you use a try DP, it's a
Mm-hmm.
little bit ridiculous for an interview.
Mm-hmm.
So that's where I asked like, how could you make this better? And you said a hash.
Yeah.
A
Yeah.
hash would be fine too, but I think a try would be better. Um,
Okay. Okay.
yeah.
Yeah, I think I understood like this equals part, and I was like, but yeah, and it would not add value the hash one because we can't really achieve the rolling hash, so I got stuck and I just like said hash and I moved on. But yeah, makes sense.
Yeah, maybe you can, but a try would just be way easier,
Yeah.
and it would be way better. Yeah,
Okay.
because then you would have like you would just compare as you go to every single word, and then you'd have like s times like the
Yeah.
length of the longest word or something, which is like
Mhm.
you're basically taking out a dimension there. And then
Mhm.
the other thing that you didn't do well, and this is like basically the only thing you didn't do well, was like your time complexity for the first thing that you said. I think you said it was like n cubed or something. So usually what I like to do, and you kind of did this for the second part, is make variables. So I could say like, n is like my word, my string,
Uh-huh.
w is like my number of words,
Uh-huh.
and like whatever something else is like length of longest word.
Uh-huh.
and then you give time complexity based on like those actual variables, because then you don't just say like n cubed, because it's like what is n, like so
Mm-hmm.
so
Mm-hmm.
I like to just give everything a variable and then give an answer based on that, and then it's like very clear that you know what you're doing.
I think I got stuck on that. What would be the complexity of that? So if the string is n and like word is w and then just say longest word is l or
Yeah,
something
so like
like
if string is n
that.
and word is w and like longest word is l, so
Uh-huh.
basically what you're doing is at every index
Uh-huh.
in the string, you are doing a string compare to every word.
To every word.
Does that
I
make sense?
so yeah, so at every index as in for every substring, right? So the number of substrings
Yes.
will be n square. And now I
So the
think
number of substrings wouldn't be n. So it's basically for the number of starting indices that you're comparing would be n. And then at each one of those, you're comparing to every word, which is w. And then to compare a string to a substring, which would be like l.
oh, I think
So
okay.
that's why I
I
said it was
think
this.
I lost my thought. I was like for every I to j, but I don't have to do I to j, but I'll do a to the word length end, which will just be me iterating over the list of the words. Okay, I think where I lost my thought was like for a string, right? The substrings will be for every I
Uh
and
huh.
every j possible, and then I'll start again at this, and then
That's
I'll
right.
do
Yeah.
that.
Yeah. So
Yeah.
so that's why I think the variables help. It's very clear.
Mm.
What? Okay. So basically, if you did a try instead, then it would be like you put every word in the try, and then your comparisons would still be n, and then it would be like L, something like that. Because you're not comparing to every word now, you're just going through the try.
Correct.
So it'd be like this plus this, which is better.
Yeah.
But I mean, I think it's pretty ridiculous to ask for bottom up DP plus a try in like 25 minutes. So
Yeah.
if this was like a longer question, if you had like 40, I could be like, oh, hey, can you do this instead or whatever.
Mm-hmm.
Okay. But basically, yeah. So your overall, just like everything else was super good. It was just the time complexity and the small, like, can it be uppercase, can it be empty, all that stuff. Um, and then I think your coding was also quite good. You did have a few small bugs, but because you can't run your code, like that's pretty reasonable. Um, Especially with bottom up, like basically the harder the problem, the more complicated the algorithm you pick, I feel
Mm-hmm.
like the more room for error is like pretty fair. If you have like all your bugs were like off by one or something, it wasn't like any logic. You had the off by one, so I think you had a couple. You had the substring being out of bounds, which you caught, and then you had another one. So I think I wrote like three, and then you caught two, and then I pointed at one, but it was like a off by one, which is like I don't think
Mm-hmm.
that matters.
Yeah. Yeah. Yeah.
And then you took 25 minutes, so that's why I was gonna say like if you had 40, I would
Mm.
strongly, because you're coding in Java as well. Like I did most of my stuff in Java, and you basically just have to do things very quickly. So
Mm-hmm.
don't overcomplicate solutions for yourself, and don't go for like some crazy optimizations if you have 20 minutes.
Mm-hmm. Mm-hmm.
Um,
Mm-hmm.
just try to get like
Just some
something
out.
pretty reasonable that you can code really quickly.
Okay. Yeah.
And that, like top down, bottom up here would be the same time and space anyway, so it's not like it's even better.
Mm-hmm. Mm-hmm.
Um,
Mm-hmm.
okay.
Makes
And
sense.
then so I'd say here your problem solving, I'd say, is like, so out of like 5 points, it would be like four, like 4.5. Like you basically got the right thing. Your time complexity was a little bit off, but that's the only thing. And then the other one is like coding. I think your coding was quite good. You basically caught all your bugs except for one. So I'd also say out of five, this would be like a four. Um, and then your communication was very good. Like I understood exactly what you were doing. Like maybe a little bit was unclear, so maybe like 3.5.
Mm-hmm. Mm-hmm.
And then like DSA knowledge, and you did bottom up, so I'd say that's like 4.5
Okay.
as well.
Mm-hmm.
So the main thing is just speed. So
Mm-hmm.
just don't overcomplicate things for yourself, and like think of straightforward solutions instead of like, oh, I can optimize here or there or whatever. Um,
Mm-hmm.
but overall, I'd say this was like if it's somewhere in between like a solid hire and like a strong hire in my opinion.
Mm-hmm.
Because like no one really like goes through an interview like flawlessly with like zero mistakes, unless they like seen the question and did a billion questions.
Mm-hmm.
So
Okay.
yeah. Okay, so for the second one, let's see. Yeah, so you restate the problem. Yeah, I guess once again, maybe you could have asked some edge cases like, can there be zeros? I think you assumed there were, so I would just ask like, can there be zeros? Can it be empty? Like all that kind of stuff.
Mm-hmm. Mm-hmm.
Let's see. Yeah, so you came up with a solution. Like I don't know if you've done this one before, but you came up with a solution ridiculously fast
Mm-hmm.
for this problem.
I've seen something similar, like a reservoir sampling or something
Uh-huh.
recently. So,
Okay,
yeah.
that's fair.
Uh-huh.
Okay, but I mean that's also like the more problems you do, the more likely you are to see something
Yeah,
like
yeah.
so
I've seen a
yeah.
version of it, like basically where we are doing the probability. Yeah.
Hmm. But either way, like
Mm-hmm.
I've interviewed people where I've given them the solution and they still like get stuck, so that's fine. Also, like if like when you get interviewed, if you get a solution quickly, they're not going to be like, "Oh, you've seen it, I'm going to fail you" or something. So,
Mm-hmm.
so that's totally reasonable. So you came up with a solution quickly. I think I had to ask you about the like. I think you were doing the 0 to 15, and then I asked you like, why would you do zero? And you basically figured out that like, oh, I can just do this, and then it's like 1 through 15, and it's fine. And then your time complexity. So this one was a little bit easier. Some time complexities are quite hard. Some are quite easy. This one was quite easy. So you got that right. And yeah, you basically had a working like plan very quickly. So I'd say algorithm knowledge quite good. Like algorithm knowledge, DSA, problem solving quite good. Um, Once again, I think you took a little bit too long. You took 25 minutes, so I gave you 50, which is fine. But like, yeah, if you do like meta or whatever, it's like 40. So
Mm-hmm.
I would also work on, speed. And there's just a couple small things here.
Mm-hmm.
So, yeah, you did have the small bug where like you access the W length or whatever, but that's like small and you have the off by one, but it's fine. Um, let's see. You let's see, handle entry split. Oh yeah. So the binary search part. So this part, I would say. So it's good to know like built-in Java or whatever binary search, but I would ask like, there's a built-in. Can I use it? Here's what it does, and
Okay.
then they'll say yes or no.
Mm-hmm.
Um, so so that like it's good to know, but it's also good to clarify.
Okay.
And then I think this part, I would say, so for me, for example, if I had to code this thing, I could do it in like 2 or 3 minutes.
Okay.
You weren't super confident, like, does this work? Right? Like,
Mm-hmm.
you had to go and like dry run it and like be like, am I off by one here? I don't know. Yeah. So I would
Yeah.
say practice that a little bit, and this should be like basically a for loop for you. And that's like a time killer if you take, 10 minutes and you could have taken two.
Okay.
Um, so these like simple things really can like kill your interview where you were doing super super well, and then you
Mm-hmm.
just like imagine like we just ran out of time. It would be kind of not great if you did super super well and then you just like ran out of time because you didn't remember some binary search index thing.
Mm-hmm.
Um, but overall, yeah, I'd say the second problem was quite good too. So I'd say this is anywhere between like given that I did ask you like pretty average level problems. Like they weren't too hard, they weren't too easy. I thought it was pretty fair. I'd say this was like a solid hire for me for like I guess you're interviewing for senior, right?
Yeah, I
Yeah,
am.
so
Yeah.
I'd say so maybe like for mid level this would definitely be a solid hire, leaning on strong hire, and then like for senior I'd say this was like a solid hire. Like there are things you can improve on, but I think still quite good.
Mm-hmm.
And also considering you've just started like studying and you have interviews in like a month or two, so you have plenty of time to like get better.
Okay.
Um, yeah.
So like when I was not confident of the snippet and I had to do this, right? You're saying it's giving a signal that I'm not confident. It would be better signal if I was confident in this part. Like I know it's in
It's
the
not even the confident thing. It's even if I don't care about the confidence, it's just purely time. Like if it takes you 10 minutes to do this because you have to run it and test it and you aren't sure versus 2 minutes,
okay.
like the
But
confidence doesn't even matter. Like
okay.
it's just time. So
Okay.
yeah.
Okay. But I'm also curious about like the part where like as simple as something as binary search, if I'm like non-confident, is it in the low, is it in the high, is that of for a senior it's
I think it's
questionable
pretty
to tell.
reasonable. I mean, it's like how often do you code binary search? And it's like these things aren't like it's pretty easy to have off by one errors in binary search. Like it's really common. And there's
Mm-hmm.
all these different binary search cases. So
Yeah.
like, so usually what I do is I try to make one kind of like one thing that I write that works for everything.
Mm-hmm.
And then that way I don't have to think about like which one is it? Do I have to return the low, the high, the who knows?
Okay.
So I basically try to come up. So I think that's good. have like default templates to use that work for almost everything, and then you can like not worry about like this. Because honestly, if I had to do something like this, like I wouldn't even know which one I'd have to return. I'd have to think about it. Um,
Mm-hmm.
so
Yeah.
that's why I just use something that works for you, that you're super comfortable with.
Mm-hmm.
And also, I guess as the interviewer side of it, it is kind of hard to see like, will this work or not? Like, like I'd have to check your code. So so at that point, it's like I'm just seeing like, are you confident about it or are you not sure? Because like you can't run it. So
Mm.
it's like, can you convince me that your code works basically? Where I can't like do this in my head, So yeah.
Mm-hmm. 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 Got it.
Um, but yeah, so what I'd probably recommend is yeah, so just I think you're doing quite well. I think like maybe when it's closer to your actual interviews, you can schedule another one if you want, and we can do like a harder one. And then we
Mm-hmm.
can do either a harder one or just less time, and then see if you're just hitting like the time requirements. Because
Mm-hmm.
I think that's the biggest concern. Like just try to do stuff faster.
Yeah.
And don't overcomplicate things, especially for like Java. Like some of the stuff gets pretty verbose. Like I did
Mm.
everything in Java, so I had to type really fast, and like yeah, so
Yeah. Yeah. Yeah.
yeah.
Sounds good. Sure. Sure. Sounds
Okay.
good. Yeah. Thank you so much. Thank you for doing this.
All right. No problem. Okay. See you later.
Thank you. Bye
Bye.
bye.